Hi guys, this is Harsh from Polytope Labs, and today we are going to see how we can use Hyperbridge GET request to read on-chain values from one chain to another chain. So for this example, we are going to use BSC testnet and Ethereum testnet. And from BSC testnet, we are going to read a balance of a user on an ERC20 token contract on Ethereum testnet. So let's get started. For this project, we are going to use Foundry. So let's initialize our project. And with Foundry, we are also going to use node modules because Hyperbridge publishes its modules in NPM packages, right? So let's also initialize our package file here. And now we need to install the dependencies that we are going to use while writing the contract. First one is the core module, pnpm add Hyperbridge core. Second is the types for the storage value, that is Solidity Merkle tree. From Polytope Labs. And the third would be OpenZeppelin Contracts so that we can use the interfaces from there. Great. Now that we have installed all the required dependencies, we need to let Foundry to know that we are going to use node modules here. And we also need to declare the remappings so that we can add the imports efficiently. And then update our remappings here a bit. Great. We have everything set up. Now let's get into coding. So we have this empty contract here. The first thing that we would need to do is to convert this contract into a HyperApp so that it can interact with on-chain Hyperbridge contracts, right? So let's first import this HyperApp from Hyperbridge. Core apps HyperApp, right? HyperApp is an abstract contract, so we need to define a function, override a function here, and that would be a function host public view override returns address, and it would return host. Let's add the variable here. We also need to assign the host in the constructor. There is also one more thing that we need to do is to approve the host contract to spend the fee tokens from this contract. So let's add the import here, dispatcher from Hyperbridge core interface, iDispatcher, yes, correct. We can get the fee token, but let's also add the IRC20 interface. Looks good. And then we can return to our core functionality. So in order to be able to read the values from another contract of another chain, we will need two core functions here. First, we should be able to send the get request, and then we should be able to receive the get response. So let's first start with get request function query token balance, as we are going to read the balance of an ERC20 token. For this, we need certain parameters. I will add it once we get to the type public returns commitment. I will let you know what this commitment mean. Our core type is DispatchGet, and we can get this from the iDispatcher. So first element is the destination in bytes encoded. So we are going to send this. We are going to read from Ethereum testnet, right? So the destination would be bytes encoded state machine ID of Ethereum testnet. So it is written in first is the EVM, that is the state machine type, and then the chain ID 1115511. This is the chain ID of Ethereum testnet, that is Ethereum Sepolia. Second is the height. So we cannot just write any height. We cannot use the height from the node. We need to use the height that is available on Hyperbridge. That basically means that Hyperbridge has synced that block height of that chain, right? So we can get this from Hyperbridge instance. I will show you how it's done, but let's just assign it to height. And then let's take height here. And then we need the keys. See, this is the main thing, keys. Basically, keys is the encoded value of what we want to read from another chain. And this is represented with the address of the contract and the slot value of the contract. So uh, in this part, the address would be the ERC20 token address, and the slot would be the exact slot we want to read for that user, right? Uh, we will show you how to construct the slot later on. Right now, let's add another parameters here, token and bytes ready to slot. And then let's declare the keys here. It is an array of bytes. 20 bytes is the address, and then the 32 bytes is the slot. And we are going to read only one value. So we are doing this. We have assigned the keys and then the timeout. So how long this get request should be active before it gets delivered on get response. So after a certain period of time, if it is not delivered on this source chain, that is this, it should be it is then invalid, and you cannot then use that, right? Timeout should be 0. So whenever a relayer sees this get request, it can deliver the get response irrespective of the time. And then we have a fee, that how much token fee that we want to pay to the relayer. Right now, it can be left at 0. And then there is some context. this is arbitrary code that you want to execute once the get response has been received. So let's keep this as 0 bytes, as we are not doing anything fancy here. Now that we have constructed our dispatch get, we need to send it through the host, right? So even if we do not have any layer fee mentioned here, there is some protocol fees, and we are going to get it using the host. Let's first get the fee token and then calculate the fee. These functions come with HyperApp. It needs the get here, and then we are going to transfer from message sender, that is the user, to this contract the amount of the fee token. And now let's send. This is now complete. You can run this and it will work, but there are also certain things that I would like to mention. First is this function can be made as payable, and you can instead of paying through the fee token, you can directly pay with some native token value, and it will be converted to the fee token. How it's done? Let's show you. So we can just add if message.value is greater than 0, then call the dispatch with the message value, else do this, right? So as a contract, we need to be doing some operations, right? Why are we sending a get request and getting a get response? So let's just add some more functionality to this contract. Let's add some events, dispatched, and then received, right? And this would be, for this commitment, we have token and then the slot. So basically for this commitment, uh, we dispatched for a token and the slot. Let's emit it here. And then we received some values, right? And I will show you how it's done. But at the same time, we also should add some storage mappings. So once we have sent a commitment, we need to mark it as true. So that means that it is blocked, means that it has not received any response, pending. And then we also need to add the actual values that was received. So for a commitment, for a key, there is some value. Let's return the commitment. Commitment is basically the hashed dispatch, so it is unique. and then we also need to mark it pending. Our first core function is done. Let's see if it's built. It builds or not. Yeah, it builds. And now we are going to work on our get response function that will be called by host and only host. So let's add that function on get response, and it takes a parameter for a get response, that is incoming get response, external override and only host. Right, let's add this type. So as a security check, we are going to check if it is an as a security check, we are going to first check if it has been marked as true or not, false or not. Incoming dot response dot the actual request, because response also consists the requests. And then we will need the storage value type, because the incoming also has the storage values, and this is for each key that we dispatch. So in the dispatch, we are just adding one request, that is this one key, then we will have one storage value. And this type comes from Solidity Merkle tree. Let me check the exact import. And then we can run a loop. Nice. For each value, we are then storing those value in our storage in this mapping. And then we can emit received for this key and then this value. This key is bytes, third bytes, and then this is also bytes. So let's update this. And once we are done with our operation, we can then mark this as false. Right? Let's also add a helper function so that we can get what's stored in our contract. And let's rename this. Yeah, it works. Now that we have our contract ready, let's go over this again so that we have a full comprehensive overview of what's done and what are the crucial parts to get your GET request working. So whenever you write a contract, first thing is to mark it as a HyperApp. And once you have done it, you need to then override this host function. And for adding the host, you can use the constructor, first thing. Second thing, you need to approve the fee token for the host for this contract, right? So this contract is approving the host and the fee token. And then the third part is whenever you dispatch a GET request, you need to get the height from Hyperbridge and not the local node or not the client that you are setting up. And for the destination, you need to uh, get the chain ID and then you need to encode it as EVM because that is the marker of the state machine, and then this is the chain ID. Third is the keys. So you now know how to construct the keys. You have the address of the contract and the slot. And how to get the slot, I will show you right now. And also, you once you are able to construct your GET request, you can dispatch it using the message value that you are going to provide. Or if you do not provide a message value, make sure that you have approved this contract for the fee token, right? So that it can automatically calculate the fee and it can take the fee amount from you. And once this is done, let's get to the get response. So make sure that you also get the naming correct because the host function uses the function signature to call this. And in the response, once you have received the correct type, you can do whatever you want with the values that you get for the key that you have dispatched, right? And then this is done. I would also like to use this opportunity to show you how you can use Hyperbridge SDK to test your contract and also the other helper functions that are very helpful for your tests. So I have created these tests and I will also link the repository, GitHub repository, so that you can just replace the contract addresses and you can run your tests on testnet. First things first, as I was mentioning that I will show you how you can get the storage slot values. We have this function for get storage slot, right? It comes from Hyperbridge SDK. And what it does is uh, it takes the address that you need to get the storage slot for and also the data. So for this, we have used the parameter as balance. So we have this we have this enum that you can use for the balance of method, balance of plus the user address that you want to calculate the slot for, because for every user address there is a different slot, right? And this is the data that you can provide to get storage slot, and this is the token address, and it will give you the slot. Once you have the slot, you can use it to call the function, right? So first one was the token address. Second is the relay fee, that is 0. As I have updated the contract here, relay fee 0. And then the third is the slot. Fourth is the height. Height you can get from Hyperbridge. How you can get it? You can import the substrate chain from Hyperbridge SDK, and then you can configure it with the Hyperbridge URL. So basically, Hyperbridge Gargantua URL, you can get it from our docs, and then you can provide other parameters here. That is this. Now, once you have initiated the Hyperbridge instance, you can now use it to get the height available for the chain that you're trying to query. it needs some parameters. So if you are using, for example, Sepolia, this is how you construct it. The state ID is this, and then the consensus state ID is basically hex value of ETH0. You can also get this from Hyperbridge docs. So if you have like this 2 hex ETH0, and that's all, right? My test is running again, no worries. Once you have the height, and then there is one more arg, that is the timeout. Here timeout is 0. You can directly call this contract, and you can get the transaction hash. Now there are certain functions from SDK, as I said, that you can use it to check your full flow. And this is how it's done. On our indexer, we index all the GET requests and the data stored on Hyperbridge. And then you can directly use the data to self-relay the GET response to your source chain, right? Uh, this is how you declare your indexes instances. So for our chain, for our test, the source chain is the BAC testnet, right? The destination chain is Ethereum Sepolia. This is the consensus state ID. This is the consensus state ID that you can get from Hyperbridge docs. And then indexer also takes a Hyperbridge chain instance, and this is how you can construct it. And then you are going to provide it to the indexer client. It also needs a query client, and that is that it requires the indexer URL. You can also get this from our docs. Uh, Once you have created the indexer instance, now you come back to the submitted transaction hash, and then you can use the hash to get the receipt, and from receipt you can get the event. And from the event, you can basically construct what would be the commitment for that GET request. And now you don't need anything else. You just need to provide that commitment to the indexer using the GET request status stream. And it will automatically run the full flow for you, where it checks if the source was finalized, if Hyperbridge has processed your request. And then once Hyperbridge has processed your request, it will get the metadata uh, and the call data that is available, so that the relayers can send it to the source chain. Why are we doing this for the testnet? Because we do not run any relayers for the testnet. If it was the mainnet, any mainnet, you need to self relay. You do not need to run this code block, because the relayers would automatically do it because they are being paid for it, right? But since this is the testnet, you need to do it for yourself in order to see the full flow and if your contract is working fine or not. And that's all. That's it from my side. Uh, if you want to get it running quickly, you can directly uh, check my repository. Let me paste the link. Hyperbridge GET request. You can directly get it from this link. But I would say that you do not clone this. Instead, you look at this and build it yourself. Because as a disclaimer, I would not want anybody to run my code in case anything goes wrong, right? There are many security concerns as well. So just look at this repo, how it's done, and then you can do it yourself by looking at it. I have also added the ABIs here. You can just check this out, copy it for your functions, and you will be able to run the full flow of this. You can also replace the contract that you're testing for, and you can update the ABIs here, and then you can update your test. And that's it. Thank you, guys.